This is question 30 from section 1 of the 2018 ECHA paper. So we're given a geometric progression S, the terms of which we denote U1, U2, U3, etc. We're told these facts about S. All terms in S are positive, and S is split into two other progressions as O and E. O is U1, U3, U5, U7, so the odd numbered terms essentially. And E is even numbered terms, so U2, U4, U6, U8, etc. And we're told that if we sum the terms of O up to infinity, then our result is 8 over 9. And we told our first term of S, U1, is 2 over 3, so 2/3. And from this, we're asked to deduce what's the sum of E to infinity. So, where on earth do we start here? Well, the key fact is this is the only real useful fact we're given, or the only thing we're given a numerical value for, that the sum of O to infinity is 8 over 9. So if we could construct some expression for the sum of O to infinity, equated to 8 over 9, we might be able to get somewhere. So, first things first, let's call S ratio R, because we need some name for it, because we're going to use it a lot. So the sum of O to infinity is 8 over 9, so that means this. So where on earth does this come from? Well, we know the sum to infinity is 1 over 1 minus A over 1 minus R, where A is the first term of a sequence. So the first term of O is U1, so the U1 on top isn't that much of a surprise. But it's not over 1 minus R, it's over 1 minus R squared. Why have we done that? Well, if you know, O goes up in multiples of 2, right? Not multiples of 2, but the terms go up in multiples of 2. So we go U1, U3, U5. So to get from U1 to U3, we take U1, we times by R to get to U2, and then we times by R again to get to U3. And so the ratio isn't R between terms, it's R squared. And so we get U1 over 1 minus R squared is equal to the sum to infinity, which is 8 over 9. But the thing is, we know U1, which is nice, 2/3. So now 2/3 over 1 minus R squared is 8 over 9. And let's simplify this a bit. So we can cancel the 2 and convert this to a 4. And times 3 by 3, we can get rid of this 3 here, and this comes to a 3. So we get 1 over 1 minus R squared is equal to 4 over 3. Let's try and solve this for R. So invert both sides to get 1 minus R squared is 3 over 4. And then we can rearrange for R squared, and we can see R squared is equal to a quarter pretty easily, 1 minus 3 over 4. Then we get R equals a half. And you might be wondering, well, what about R equals minus a half? Well, the key is in this. We're told all terms in S are positive. And if R was minus a half or any negative number, then U1, U2, U3, they would alternate between positive and negative. Because we've got a positive number, times it by a negative ratio, we get to a negative number. Then that will go positive again, negative, etc. And so R equals minus a half breaks this line. And so R must equal a half to ensure all terms in S are positive. So we've got R. That's not quite the end of the question, but we're nearly there. Because what we're asked is the sum of E, to find the sum of E to infinity. So we know that's equal to this. Because the first term of E is U2, which is going to be U1, 2/3, times R, which is a half. So 2/3 times a half. And over 1 minus R squared, because the ratio, again, is going to be R squared, because we times by R twice to go from U2 to U4. We don't go up in steps of 1, we go up in steps of 2. And R squared is a half squared, just a quarter. So we get this, 1 minus a half squared on the bottom. So let's try and simplify that a bit. So that's just 2/3 times a half is a third. And a half squared is a quarter. So 1 minus a quarter is 3 over 4. And now working with this, we see bring the 4 up to the top, and we get 3 times 3 on the bottom, which is 9. So we get 4 over 9 as our sum of E to infinity. And that correlates with option A in a multiple choice, and so our answer is A.